Hello. Since my students and friends ask a lot of questions, I decided to answer your course questions in this channel. If you have questions about physics, math, electrical engineering, and digital, or you are struggling to understand a scientific concept in one of the aforementioned fields, please put in the comment below. I will explain it for you later. Okay, a friend of mine from Germany asked me a question. In this question, she asked me how to normalize endpoints when we have endpoints in two-dimensional system. So for example, in this figure, you see 6 points in blue dots. They are in two-dimensional system, X and Y. Her professor asked her to transfer it to the new system, which is also two-dimensional system, and normalize them. So all the points will be between 0 and 1 in x-axis and 0 and y in y-axis. So what she did, she used a scaling factor, which was wrong, and transferred them into this two-dimensional system. So you see they are all between 0 and 1, but what her professor wanted was this one. You can see over here. So they are between 0 and 1, but they are not exactly between 0 and 1. I explain it why. Because the minimum x should stay at 0 and minimum y should stay at 0. But over here you don't see the minimum x, which is, for example, this point. Look at this point, okay? So we have 0 over here, red 0. But what she did, 0 is over here and 1 is here. So the maximum point should stay at 1, which is here. But what she did was there. So it means her scaling factor was wrong. For example, when we do normalization and we want all the points be between 0 and 1, they must stay at 0 and 1. It means the minimum one must stay at 0 and the maximum one must stay at 1. So this scaling factor is wrong. Okay, I have proofs over here. If you want to see the mathematical proof, just let me know in the comment below. But I'm going to explain it here. So we have endpoints. We show the points in our original system by v. So if I see we have vxi, it means the x dimension of v point, and I, which lays between 1 and n. It means we have n points in our system. And vy means the y uh, scale of, the y-axis of my point, which is v. And u is my new coordinates. So ux and uy represent my new points in the new system. So what we need is shift operation as the first step. So for the first step, we need to shift our system. Why? Because we want to go and stay at the minimum level of the system. For example, if you have a point at 3 and 4 in the original system and you want to transfer it to the new one, and you want to say now the 3 and 4 point, this is 3 is the minimum x and 4, for example, is my minimum y. Now 3 4 must be 0, stay at 0 and 0 in the new system. So you find the minimum x. For example, if you have 4 points, the minimum x among all those 4 points. For example, the minimum one is 3, so you have to shift shift all your system by 3. It means the all x-axis will be subtracted by 3, and the minimum y, if it was 4, so you have to subtract all the y-axis of your points by 4. So you have new points after shifting. and then you need to scale. So now because we are going to scale it down, so you have to scale them down because we want to stay between 0 and 1. So you have new points, find the new points, which is w, and w has two axes because we are staying in the two-dimensional system. So you have x and you have y. So wx is the maximum x and wy is the maximum y. So now you divide all your points by w. So it means all x-axis must be divided by wx and all y-axis must be divided by wy. So now, for example, I have 2 points. The first point is 3 and 4, and the second point is at 10 and 10. So first, you need to shift them. So what is the minimum value for x? You have two values for x, 3 and 10. So the minimum one is 3. So you have to shift by 3, the x-axis. So 3 minus 3 would be 0, and 10 minus 3 would be 7. And now you have two y points for y. So 4 and 10. So 4 is the minimum value between 4 and 10. So 4 minus 4 would be 0, and 10 minus 4 would be 6. Now the new points after shifting would be 0 and 0, and 4, 10 and 10, they will be shifted to the new point to 7 and 6. Now you need to scale them down. So as I said, you find the maximum value for scaling them down. So what is the maximum value for x-axis is 10. And what is the maximum value for y-axis? Again is 10. So now, because you don't consider 10 now, you consider 10 after shifting. So you have 7 and 6. 6 for x-axis and 7 for y-axis. So you need to divide them by 6, the x-axis by 6 and the y-axis by 7. So now you get 1 and 1 for the second point and 0 and 0 for the first point. So after shifting and scaling them down, you have these two new points. So 0 and 0, 1 and 1. 0 and 0 represents 3 and 4 from the previous or original system, and 1 and 1 in the new system represent your previous points, which stayed at 10 and 10. So again, her professor asked her, when you shift, when you go to the new system, coordinate system, the distance between these 2 points must remain the same. So if you do the same procedure as I explained it now, the distance, the professor asked when the distance must decrease between all the points and they are scaled down by the same factor. For example, we have just 2 points. It means we have just one distance. So the distance between these 2 points is 9.2, and for new points, the distance is 1.4. So this means this is a scale by 6.5, the distance between these 2 points. So if we had more number of points, what would happen to our system? We want to see the distances between the points not remain the same. They scale down or up by the same factor for the system. Because we are scaling down, it means they are scaled down by the same factor. So now consider 4 points: 3, 4, 10, 10, 8, 5, and 7, 3. So again, what is the minimum value for the x-axis is 3. You need to shift them to subtract all the x points by 3. And what is the minimum for y? 3. So it means you need to subtract all the points y points by 3, and then after that, after subtraction, you find the maximum value for x and you find the maximum value for y. Then divide all new points after shifting by the maximum value. So what would you get? So you have these 4 points. Now after shifting and scaling, you will get these 4 points. So as you can see, I have the minimum points staying at 0 and the maximum at 1. So I have all the points exactly between 0 and 1. So now let's go and see the distances between the points. So the distances between the points are 9.2, 5.1, 4.1, 5.4, 7.6, and 2.2. So now the new distances would be 1.3, 0.7, 0.6, 0.8, 1.1, and zero point 0.3. If you calculate and divide the previous distance by the same distance, you see that all the new distances are scaled down by the same factor, which is 7. So if you want to see the mathematical proofs for that one, I prove it in two ways. This is the first proof and this is the second proof. If still you want to see the proof mathematically and you want me to explain the ways how I prove them, how I prove this one mathematically, just let me know in the comment below so I will explain it later.